Hello guys, what's up? Welcome to my channel King Coder. In the previous video, we have solved the problem of minimize size Subarray sum. So today we are going to solve another problem of prefix sum, that is Subarray sum equals k. So let's jump onto the problem. The problem statement says that given an integer array nums and an integer k, return the total number of subarrays whose sum equals to k. So there is an integer array, let's say arr, and the k is equals to 3. So we need to find number of subarrays that the sum is equals to k. So one subarray can be 1 2, 1 2 can be one subarray, 3 itself a subarray, so the sum is equals to k. We can see 1 1 1 is a subarray, so 1 1 1, 1 2 is a subarray again. So there are 4 subarray, so we will return 4. So let's see how we can solve this problem. We can use a prefix sum approach, that is we can add all the elements and we will check with k. So let's call a variable sum is equals to 0 initially. So I will add this element first 1, so sum is now 1. I will again check 2 because 1 is not equals to 3, so this is not a subarray. I will add this 2. Now sum is equals to 3. So 3 is equal to 3, so it's a subarray. So I will count 1. So c equal to 1 now. Again I will add this 3. So sum is now 6. 6 is not a subarray. 6 is not equal to 3. So it is not a subarray, but we can see that 3 is itself a subarray. So there is a problem. So how we can solve this problem? We can see that 6 minus k, it means sum minus k equals to a particular value. If this value already existed in the previous sum, then we can say that the this is a subarray. Then we can say that this is a subarray. Let's say if I take the prefix sum of all the elements, so initially it will be 1, then it will 2, then it will 3, because it will add this, then it will add 6, then it will add all these elements, so 5 6 4 10, and like this. So initially I come to this 1 is not equals to 3, so this is not a subarray. 3 is equals to 3, so this is a subarray. 6 is not equals to 3, so this is not a subarray, but we can see that 3 is a subarray. So what I can do, we will use this formula. We will use this formula. Sum minus k equals to val. If val already exists in the prefix sum, then we can say that it is a subarray, and I will count it by plus 1, so it will be 2. We can see that sum, that is 6, 6 minus k equal to val. Val already existed in this prefix sum, so it's a subarray. Now I will add 4, so now sum is now 10. So I will check 10 minus 3 is exist in the array. No, there is no 7 that is exist. So I will again add next element, that is 11 now. 10 plus 1, 11. 11 minus 3, that is 8. Is 8 exist in the prefix sum? No. Let's add all the element first. So it will 10, now it will 11, 12, 13 and 15. Okay. So now it will check 10 minus 3. Now it will check 11 minus 3, that is 8. 8 exists in the map? No, 8 doesn't exist. So it will again add, so it will now be 12. 12 minus 3, that is 9. 9 exists? No. Now it will add the next element, that is 1 again, 13. 13 minus 3, that is 10. 10 exists in the map? Yes, 10 exists here. So it does mean that there is a subarray that is containing 111 that is responsible for this k. I hope you understand this approach. This is the main formula. So we can see that I need to check every time in the prefix sum array that the sum minus k exists in the not. If the sum minus k is equal to val and the val is exist in the prefix sum array, then we can say that there is a subarray exists that the sum is equals to k. So we will again now add 2, so sum will be 15. 15 minus 3, that is 12. 12 exists in the prefix sum array. Yes, 12 exists here. So again we will count. So now count will be mine 4. So we will return 4. Now why this formula works? Let's see that. So we have the array 1 2 3 4 1 1 1 and 2. For prefix sum, we can say that this is 1, this is 3, this is all the element sum, so it is 6, all the element sum, this is 10, all the element 11, all the element 12, all the element 13, and all the elements, that is 15. So all the element left of 2 and including 2 is 15. We have given k is equals to 3. So we are adding first element, that is 1 here. We are adding 2 element, that is here. We are adding 3 element, that is here. We are adding 4 element, that is here. If we have k equals to 3 and we are subtracting this element, let's say for 6, we are subtracting 6 minus 3, then we are getting the 3 itself, and 3 already exists in the prefix sum array. Then it means that this is the element that is a subarray itself. This is why this formula is working. We can see that for this element 15, 15 minus 3, that is 12. 12 exists in the array, this part, in this part. This is 12 and this is 15. So it means there is 2 elements that is causing the sum is equals to k. I hope you understand this approach. So how we can solve this problem? We can simply create a prefix sum array and we will check again and again and again for this val. We will traverse every time we found a val. So this is how we can solve this problem. So this is basically big O of n square kind of time complexity, because every time we need to traverse the same array every time we found this sum minus k equals to val. So space complexity will be of course big O of n, as we have created a prefix sum array separately. So now how we can optimize this approach? Let's try to optimize this. So for optimizing, we will use a simple concept, HashMap concept. So let's see how we can solve this. Okay, so in optimal approach, we have created a HashMap and we will use this algorithm to find the required answer. So in the prefix sum approach, we have seen that we will check again and again in the array, but in the HashMap, we can check with this function that contains key. In this function, we can check in whole HashMap. So this is a better kind approach. So this is the optimal approach. We can use this. So in the HashMap, if you don't have any idea of HashMap, then I will just simply tell you that in the HashMap, what we can do, there is 2 elements, that is key and one is value. Let's say I have a key, let's say 3, and the value is 2. We can say that 3 is mapped to 2. 3 is mapped to 2. It means whenever I will access this 3, I will get this 2. If I access this 3, I will get 2. You can say that this is a frequency. You can say that sometimes in counting part we can say that if we adding 1 1 1 and 1, so if we add 1 and let's say 4, it means that 1 is occurred 4 times in a array. Then we can say that 2 is occurred 2 times, 3 is occurred 1 time, 4 is occurred 1 time, like this. Like this you can say that HashMap works. So in this position, what we can do, first we will add every element like we have done. So sum initially 0, we will add the first element, so sum will be now 1. I will check if 1 exists in the hash map or not. You can say that the hash map is same as the prefix sum array. So I can say that a hash map is equal to prefix sum array. Prefix sum array. If you have clear idea of the prefix sum array, how we can create it, how we can traverse in the prefix sum array, how we can find sum minus k equals to val, then find the val in the prefix sum array, then you will understand this easily. So now first sum is equals to 1. In the prefix sum, what I can do, we can store every sum in a different index. Let's say first index the sum is 1, then second index we will add these two elements, so it will be 3. Next third index, second index, it will be 1 plus 2 plus 3, that will be 6, like this way. But in this position we will use a simple variable to find this sum. So sum is 0, now initially 0. I will add this element 1. I will check if 1 exists in the hash map or not. I will check simple map dot contains key sum minus k. So we are checking, that is the simple thing, sum minus k is equals to val. In the prefix sum, what I can do, I will check val in prefix sum, and if I found val, then I can say that there is a subarray. So in the same way, I will check sum minus k, that is val, in the hash map. If it is contains, then I will increment the frequency. This is the frequency. It means the value part, that is frequency. I will add this frequency with the answer. So I will check for now k is equals to 3. I will check 1 minus 3. 1 minus 3 is minus 2. Minus 2 exists in the map or not? Initially map is empty. I can say that I will put 0 and the frequency will be 1 in the map, but now let's say there is no element, but it will required 0 and 1 required. So let's say now there is no element, so it will check minus 2 exists in the map, it doesn't exist, so it will put map.put in this form. We can say that put, let's say 0 and 1, so it will add 0 in the key part and 1 in the value part. So let's say minus 2, let put minus 2 in the map, so value will be, if minus 2 already exists in the hash map, then it will just simply increment the frequency, or you can say that it will increment value by +1. Else if doesn't exist minus 2 in the hash map, then it will simply return 0. It will simply return 0. So we are using this part map.get or default. Map.get or default, what I can do, it does that map.get or default, it will check sum, or it will return 0. If the sum exists in the hash map, then it will return the frequency part, else it will return 0. So I can say that minus 2 doesn't exist in the hash map, so it will return 0. So this will be 0 and +1, so it will be 1. So minus 2 and the value part will be 1. Now sum is again, now I will increase the sum, so it will add 2, it will be 3. 3 minus 3, it is 0. It will check 0 exists in the map or not. Now initially let's suppose this is not a part, let's suppose So initially you can see that in the hash map there exists only one element, that is -2 and 1 in the hash map. But this is a perfect array, this is a perfect subarray, we should count this, but there is no element that is 0. So what I can do, we will initially declared 0 and 1. We will initially put 0 and 1 in the hash map, because if the element is 0, it means I can say that there is a array only containing a single element. There is a array only containing a single element and k is equal to 3. Now what will be, the sum is equal to 3. 3 minus 3 is equals to 0. 0 doesn't exist in the hash map. So but this is a perfect subarray, so we will return 1. So what I can do, we will add this 0 and 1 part. So this is the part that we need to put first. So now it will check 0 and 1 exist. Yes, it is exist. So answer will be map dot get sum minus k, answer plus equal to map dot get sum minus k. Map dot get, what does it do? Map dot get sum minus k, that is 0. Sum minus k is 0. Map dot get sum minus k, it means it will return the value part. If I say map dot get -2 -2, it will return 1. So this is how we can add 1 with answer. Now sum is now 6. 6 minus k, 6 minus 3 is 3. 3 exists in the map or not? We will check map dot contains 3. It will say no, it doesn't contains, so it will not come here. Map dot put, it will put simple, it will simply put this sum. This is 6. Okay, this is not -2, this is actually, we will put this sum part, so it will be 1. So in the 3 part, yeah, it's perfect. So we will put this one for and increase the frequency. Now for the sum 6, now for the 6 it will put 1, like we have said, for 1 then 3 then 6. You can see that there is a simple. Okay, so for 3 there is no 0. You can say that map dot contains, it doesn't. So we will add also we will add this part 3, as this is my prefix sum, of course, and we have checked all the parts, so we will need to add all these parts here. So 3 and 1 and 6 and 1. Okay, so it will check 3 exists in the map or not. Yes, 3 exists in the map and the frequency is 1, so answer will be 2. Now sum is equals to 10. So it will check 10 minus 3, 7 exists in the map or not. 7 doesn't exist, so simply it will add 10 and frequency will be 1. I need to just simply add this sum every time, as we have add this every time, just like this. So after that it will check for 11. 11 minus 3, 8. 8 doesn't exist, it will add 11 and increase by frequency 1. Sum will be now 12. 12 minus 3, 9. 9 doesn't exist, it will add 12 and 1. Okay, now sum is 13 and 13 minus 3, 10. 10 exists in the map, so answer will be again plus 1. So now answer is my 3, and I will add this 13 with a frequency of 1. Now sum is 13. After I will add, I think, plus 2. After 13 it will be plus 2, so it will be 15. 15 minus 3, that is 12. 12 exists in the map or not? 12 exists in the map, so it will be again at plus 1. So answer will be 4. After this, all this part it will check again, but there is the end of the array, so it will return only my answer 4. So let's now talk about the time complexity of this program. So time complexity will be big O of n, because we have traversed this array only one time. While traversing, we have calculated the sum, we have checked sum minus k equals to val or not, and we have found this val in HashMap. In HashMap, the find is big O of 1. If I found this val in the HashMap, then the time complexity is big O of 1. It means it's a constant time. You can find this. So this is total big O of 1, big O of n time, and this complexity of course big O of n, because we have created a hash map. So this complexity is big O of n. Now let's try to code this in Leetcode. So you can see that we have created a hash map like this way, hash map integer in integer, because key and value both are integer type. So this is integer comma integer. We have created variables like n equals to nums dot length, frequency 0, sum 0, answer 0. So there is no need of frequency here, sum and answer 0. Initially we have put in the map that is 0 and 1, as I have said that for the single element 3, like 3 and k equal to 3, it will return of course 1. So we have to put 0 and 1. In the for loop we have done a simple for loop, and we have add every element sum plus equal to nums of j. If map dot contains key, if the key contains nums of a sum minus k, that is val sum minus k equal to val, if the val contains in the hash map, then simply increase the frequency by answer plus equal to answer plus equal to frequency, and after that we need to add that sum in the hash map, as we have done this in the prefix sum array. As we have done this in the prefix sum array, we have every time we have added the sum every time 1 3 6 10, like this way 1 3 6 10. So this part also included in the hash map. So after that it will return my answer is 4 in case. So let's try to run this code. You can see the answer is perfect. Let's try to put this test case 1 2 3 4 1 1 1 2. So 1 2 3 4 1 1 1 and 2, and k is 3. Let's say the answer is 4. Yeah, the answer is 4. So we will submit this now. You can see that it is submitted perfectly. If you have any doubt regarding this problem, then please feel free to ask me in the comment section. I will try to make another video and try to explain it. Else you can again watch the full video. You will understand. So thanks for watching. Don't forget to like and share and subscribe our channel, and don't forget to like the video. Thank you.